That's
know.
good. All right, guys. So let's go ahead and jump in. So we're still on part two of volume one of the CCNA 200-301 official cert guide, right? So we finished chapter six. Gave you guys a breakdown in the last video regarding um, securing user access within the CLI using external remote authentication, right? So cover that. Hope it added value. Um, and so now we're moving on to the last chapter of part two of implementing Ethernet LANs, right? And chapter two, title of it is configuring and verifying switch interfaces. Okay. All right. So a couple of things that this chapter is going to follow, that's going to cover following the exam topics, all right? 1.0, network fundamentals. 1.1, explain the role and function of network components. Okay. 1.1.b, layer 2 and layer 3 switches. Okay. 1.3, compare physical interface and cabling types. Okay. 1.3.b, connections, Ethernet shared media and point to point. And 1.4, identify interface and cable issues, collisions, errors, mismatch, duplex, and or speed. Okay, let's go ahead and jump on it. All right. So we had multiple labs. We talked about multiple theories of the different types of cables. We talked about straight through cables. We talked about crossover cables. We talked about IEEE standards, right? As far as 10 megabits per second, 100 megabits per second, 1,000 megabits per second, right? And the different names or what have you, right? All fundamental building blocks, right? That you guys need before moving on to part three. Part three being implementing VLANs and STP, right? But we need to cover this part, right? Because you need to understand um, layer one, right? And we're gonna, what we covered so far, we're talking about physically creating an Ethernet LAN, right? A couple of things you'll have to consider, right? Um, we talked about all things layer one, but we need to talk about layer two, right? And all the rules that cover um, layer two. Okay. So let's talk about auto negotiation, right? To start off this chapter, right? So typically, right, um, you'll have different type of ports and port speeds, right? As you guys can see here, let me go ahead and get my handy dandy notes, right? Because I know you guys can read, right? We have 10 to 100 megabits per second, right? So that's a port that handles both 10 or 100 megabits per second. Or you can have a port that handles 10 or 100 or 1,000 megabits per second, right? Outside of this book, outside of this, outside of this exam, there's actually switches, right, that actually handles higher speeds than gigabit per second, right? They're called multi-gig ports, right, on these switches, right? So it can handle 2.5 and 5 gigabits per second, depending on if you have the right copper cable, Cat 6 and above, or what have you, can go ahead and handle it. And that's where the world is going, right? So, right, using hardware that supports multiple standards and speeds allows for much easier growth and migration over time, right? This is along the lines of when we're talking about wireless, right? And supporting different wireless standards and speeds, right? Over the air, right? So, and that's just one part of it, right? So, and I want to, and I'm jumping ahead, but one of the things that whenever you plug a device to a switch, right, it learns a lot about the other side, right, the other device, the host that's connected to it, using fast link pulses, FLPs, and we'll dive into that, right, because that's how that auto negotiation works, right? That fast link pulse, right? The electrical signal that goes through says, hey, now I can negotiate with you what your speed and duplex needs to be. Okay, right? So a lot of the older devices, right? Maybe you're in an environment where it only supports 10, 100, and 1,000, right? you may have devices as well, legacy devices within your environment that's going to cover older speeds, right? Um, some devices may cover newer speeds, right? All in all, if you do not change the configuration, auto negotiation, it is going to give devices, right, the speed and the duplex, right, that it can support and what the device can handle, right, without you having to jump in and manually configure this for the port. Okay, great feature, right? And great implementation by the IEEE. Okay. Um, IEEE defines the process by which both devices on each link tells the neighbors, and that's FLP, fast link post is what I was talking about. Tell the the neighboring devices their capabilities, right? Once both endpoints learn about the other, they use the standard with the fastest speed. Okay. Auto negotiation also defines full duplex as the preferred option over half duplex, assuming both devices support that option. Guys, this is something you need to remember for the exam and life outside of the exam. Okay. All right, let's keep going. I'll take away this pencil. All right. Oh, and let me take away that jar. Right. Okay. Let me close that. So before we started recording, we were talking about a working state and a non-working state, right? So let's talk about auto negotiation in a working state, right? So in a working state, right? What's going to happen whenever these switches use auto negotiation? What's going to happen, right, is you're going to connect your PC to the switch, right? It's going to go ahead and send a series of fast link pulses, right, to the switch. It's going to send it, FLPs, fast link pulses. There's data, right? Similar to BPDUs, there's going to be data within those FLP messages, right? It's going to include bits that identify the Ethernet standards supported by the device and the duplex ability, right? In effect to declaring the speed and duplex settings supported by the device, right? So let's say I have a PS2, okay? And I plug that PS2 into the switch, right? Well, the PS2, right? Example purposes, this is not exact. It supports 10 to 100, and it supports half duplex and full duplex. Okay. I just spoke to you, right? I just told you, right? And IEEE concepts, right? Fundamental concepts is that with auto negotiation, right? Full duplex is going to be the preferred option over half duplex every time. And of course, when both endpoints, right, are communicating these FLPs, right, the fastest speed is going to be chosen as well. I need you guys to remember that. That is the working state. Okay. All right. So let's keep going. Clear that out. Okay. So I got that squared away. So the thing about the FLPs is that FLPs work at layer one. They don't work at layer two. They work at layer one, right? Because it's doing electrical signaling, right? So they communicate via ones and zeros, right? The switches ASICs that connect to the data plane, right? They're able to translate that and know, hey, this is what I need to supply this endpoint. Okay. Um, and it's independent to, like I said, layer two and anything from a Ethernet frame transmission standpoint. Okay. So you guys see this example, right? We see, let me change the color. We see here, right? We plugged in a device that has a speed of 10, right? It's only capable of 10 megabits per second. And it's also capable of full duplex and half duplex, right? Based in the theory that we just spoke about as far as the fundamental pieces of auto negotiation, right? What's chosen here, right, is we have 10 megabits per second and it chose full. It's capable of half, but it chose full, right? Let's look here. Same thing, right? It's capable of all three speed types that we spoke about earlier in full duplex and half duplex. Here's the result. It is always going to choose the highest speed and, of course, full duplex over half duplex if it is capable to do so. This is in a working state. Okay. Let's take a quick break right now. Any questions? Anybody want to come off mute? Have any questions? See how it works? Does this make sense? Okay, excellent. I'll take the silence as a yes. Oh, sorry, DeMarco, go ahead.
No, I was just gonna say I kind of understand how it worked far as the 10 and 100 and 1,000 base T
Okay,
or duplex.
got you.
It's just when they get into like and I got it notated like what is it? Auto desirable, I think.
No, so that's a different theory. So
Oh,
that's talking about dynamic trunking protocol.
oh, all right, got you, got you.
Yeah, that's something different. Yeah,
Okay,
that's something different.
cool.
Something different. Um, but let's break down the logic, right? And you guys, since it's recorded, this guys will help you out, right? So let's talk about the logic within this picture. I know I gave you guys the high level, but I want to use the technical terms so it makes sense, right? So PC1, right? We're looking at PC1. Okay, PC1 sends auto negotiation FLPs, right? That declare support for 10 megabits per second only, right? Not 100 megabits or 1,000 megabits per second, and support for both full and half duplex. And guys, I'm reading actually from the book now. Okay, the switch announces support for 10, 100, and 1,000 megabits per second in both duplex settings, right? As a result, both the PC and the switch choose the fastest speed, 10 megabits per second, and the best duplex, full, right? That both devices support. And this is the same across the board. Okay. So to summarize, right? Right? Both endpoints, right? Host anything, printers, whatever video game systems, both endpoints send messages out of band compared to any specific data transmission, right? Using FLPs. Okay. These messages, they operate at layer one. These messages, they declare all supported speed and duplex combinations, right? After hearing from the link partner, right? Each device chooses the fastest speed supported by both devices, right? And the best duplex, right? Full being better than half duplex. And of course, the speed and duplex is assigned, agreed upon, and configured. Okay. Let's talk about auto negotiation results when only one endpoint uses auto negotiation. Okay. So I already showed you guys what it looks like in a working state, right? To where both devices use auto negotiation, right? Um, if you go ahead and look at Cisco documents, Cisco white papers, as they're called, Cisco, they're going to go ahead and recommend using auto negotiation on both ends, right? Um, two endpoints or Ethernet links that support it, right? But for some reason, and there will be reasons that you have to disable it, right? A good example is sometimes whenever you're depending on your ISP, that CPE device, that customer provided equipment, it may need to be configured in a certain way to where you need to turn off on negotiation and manually set the speed of duplex. That's a use case, right? That is a case where you may have to disable it, right? You have to make sure that you configure both speed and duplex on both sides of the links. Okay. So for instance, right, some installations, they prefer to predefine the speed and duplex on links between two switches, right? And we'll go over those commands, right, within the lab, right? But just to speak, right? Um, let's say I want to go ahead and configure um, interface gigabit 0/1, right? I would get into the context of that interface, right? So I can go ahead and input those subcommands, right? And then I'll use the command speed, right? And go ahead and configure the speed that I want in megabits per second. Same thing for duplex. I'll go ahead and for context for that command, right? That subcommand I'll go ahead and put in duplex, right? And share, do I want full duplex or half duplex? So it'll be full or half, right? However, right, a lot of devices, their capability to disable auto negotiation, right, can be because of a design issue, right? Maybe the engineer, grab a device and says, hey, we can't use auto negotiation on this end, um, but we can use it on the other end, right? And what can happen is if you do that, you implement that in your environment prematurely, right? We can have a duplex mismatch. And what we talked about in earlier chapters, when you guys were learning about bridges and broadcast domains, is that you can actually have late collisions, right? So to understand all of this, right, we need to first consider that the device with auto negotiation disabled, right? So let's talk about the device that has auto negotiation disabled, right? It must use some type of physical layer standard, right? Um, Typically due to like static config, right? Let's say the ISP is using a static configuration, right? So it'll go ahead and start sending Ethernet frames, right? Um, that conform just to the standards, right? It doesn't send FLPs. It just sends Ethernet frames that conform to the standard, right? The other device, right? Let's say my Cisco device, right? The one that's using auto negotiation, so I can be clear, sends fast link pulses, right? And it can examine the incoming electrical signals of those Ethernet frames and notice differences between the signals used for 10 base T, 100 base T, and so on, right? So my Cisco router, knowing that it uses the same standard, solving the question of what speed to use. The choice of using duplex required using a default, right? If the speed is 10 or 100 megabits per second, hear me out. The device attempting auto negotiation uses half duplex. Otherwise, it uses full duplex. Does that make sense? And the scenario is we have one device not using auto negotiation. The other device is using auto negotiation, right? So this logic I just explained, right, by auto negotiation, right, has disabled auto negotiation, has parallel detection, right? And just to read off the PowerPoint right here, summarize has speed, right? Detect the neighboring device's physical layer standard by analyzing the neighbor's incoming frames, layer two. Use that speed. Duplex, make a default choice based on speed. Half duplex if the speed is 10 or 100 megabits per second. Full duplex if faster. Okay. So if I'm working with DeMarco, he's the ISP, right? We don't, we're having issues. We don't talk anything about layer one, right? Um, and of course, I'm having, my link is bouncing, right? Packets are getting lost, end users are complaining, and I'm like, all right, let's work it out, right? Um, we spend hours and hours, right? Of course, we're not even using the OSI um, model, right? And we finally get to using the OSI model after hours and hours, and we find out that he has defaults. He has static, right? Statically set his speed and duplex, right? So he's not using auto negotiation, right? I'm using it, right? But his setting is 100 megabits per second, right? And he has full set, right? Auto negotiation is going to adjust from what is communicated, even though the other side doesn't use auto negotiation. Okay. And to note, right, Ethernet interfaces using speeds more than 1 gigabits per second. will use full duplex. Okay. All right. This is just a diagram. I won't go over this one because I think I covered most of the logic. What it looks like whenever auto negotiation is disabled on the other side. Okay. So the switch, of course, briefly I'll speak about it. The switch has auto negotiation enabled. Okay. These endpoints, manual settings, auto negotiation disabled. Okay. And so what we have is 10 100 megabits per second, right? It's possible to use, but the settings that's statically configured is 100 megabits per second, and the duplex is set to full. Since auto negotiation is not configured on the endpoint, the switch is going to say, based on the IEEE standard, your speed is 100, I'm going to set your duplex to half. So DeMarco set, right on his side, his router to 100 megabits per second and a duplex to full. That does not mean my switch is going to automatically say, hey, I'm going to set this to 100 megabits per second and I'm going to be full as well. No, my switch is going to use the IEEE standard and say, hey, based on, right, RFC, right, for auto negotiation, right, anything that they have in for the IEEE, 10 and 100 megabits per second, I'm going to set to half. And this is what happens here. Okay. This is what we see here, right? 1,000 megabits per second, right? Just like we learned in our theory, it uses full. Switch is going to determine that. It's going to say, all right, excellent. I detected you're using 1,000 megabits per second. So I'm going to set the duplex for full, right? We see that here as well, right? 10 megabits, half, right? Then since you're 10 megabits, since your speed is 10 megabits per second, I'm going to set your duplex to half. Okay. Hopefully that makes sense. Okay. Go ahead,
Hey,
DeMarco.
hey Dave. So
Yes, sir.
for PC1, just
Yeah.
because it's set, just because it knows it can use 10 or 100, the switch is going to set it at half.
Yes.
All right.
Based on the IEEE auto negotiation standard,
Okay.
right? So, but let's take a closer look at this, right? I thought it was gonna be quick with this picture, but now I'm about to have fun, right? So, right, we have our connection, right? This result, right, of this connection is people a duplex mismatch.
Gotcha.
Duplex on one side is full. Duplex on the other side is half, right? They both use the same speed, right? However, right, PC1 using full duplex does not attempt to use CSMA CD, right? Carrier central multiple access with collision detection, logic to send frames at any time. Switch port, gigabit 1/0/1, using half duplex, does use CSMA CD. What does that mean? Right? Right? So what this means, right, from the switcher standpoint, right, it believes, hey, collisions is going to occur on this link when sending a frame, since I'm running half duplex, right? So if I try to send a frame while PC1 sends a frame, right, the switch is going to detect that PC1 is sending a frame. The switch is going to detect it since it's running in half duplex. It's going to stop transmitting frames. It's going to back off. It's going to say, hey, you got it. Go ahead. Right? You got it, boss. Go ahead. Walk through. Right? It's going to back off. It's going to do, it's going to send an electrical signal that says, hey, is this channel clear? Then it's going to send a frame because it is operating within half duplex, right? So as a result, right, what's going to happen is the link is going to be up because going back to this ISP example between me and DeMarco, right? The link is up. Me and him are right. We're us of course having long day and not using the OSI model, which of course I I hope you guys are using the OSI model whenever you troubleshoot anything at work. But when we finally decide to use the OSI model, we determine that the link is up, but it's performing poorly. And it's performing poorly because we have a duplex mismatch. Okay? Does that make sense?
It
Yeah,
does.
it does.
Okay. Okay. All right. So let me clear this and let's move forward. Okay. So let's talk about auto negotiation with hubs, right? So sorry guys, my cousin, she's expected to have her her baby at any point. So I'm watching the chat from my cousin-in-law. So sorry about that. So let's talk about hubs, right? We just talked about switches to endpoints. Let's talk about how hubs impact auto negotiation, right? Hubs by default do not participate in auto negotiation. They do not generate FLP messages, fast link pulses, right? And also, they do not forward auto negotiation FLPs sent by connected devices. As a result, devices connected to a hub receive no FLP messages and use only IEEE auto negotiation parallel detection rules, right? That can work. You can have it in your environment, but again, what's going to happen if what's detected on your network, right? You have a link for 10 megabits per second, right? It's going to go ahead and see that from the hub. It's going to say, hey, I'm going to set all of this to hash, right? These endpoints might be capable of running full, but um, using the IEEE auto negotiation parallel detection rules, it's going to say, hey, 10 to 100 megabits per second, I'm going to set your duplex to half. Okay, so this is what auto negotiation looks like whenever you have hubs within an environment. Okay, let's keep going. So we spent some time talking about um, theory, what it looks like in the working state, and in a non-working state, right? And an adverse state as well, right? So let's talk about configuring auto negotiation, speed, and duplex, right? Um, so what are some prerequisites? One thing I love about Cisco white papers and even Juniper and Aruba, a lot of vendors, right? Their technical documents in their white papers, they have this section that's called prerequisites, right? Um, and we've spoke about config checklists in earlier chapters. This is the same thing, right? So for your Ethernet link, right? And I'm basically going to cover some prerequisites. For your Ethernet link to work correctly, the link needs a working cable, right? And the endpoints need to use the same physical layer standard and duplex setting. With Cisco switches, the default switch setting to use auto negotiation should make the switch use the right speed, should use the right speed, and duplex so that the link works. Okay, so you guys can see by this diagram, right? This is just a topology that's showing you, right, that if we have a layer one connection, bring my pencil out. We have a layer one connection, right? No other configurations on the links, right? Just using auto negotiation by default. The endpoint comes up, it works, right? If we're looking at, PC2, the endpoint is powered on, but there's no cable connection. So of course this is not working, right? Layer one doesn't exist. So those FLP messages can't be sent from one to another, right? Now the use case for endpoint number three, right? It's cabled, but it's powered off. So if it's powered off, it can't send those electrical signals that are FLPs in the first place. Make sense? Okay, let's keep going. Right? So how can we confirm that our switch interfaces are using the default settings, right? My favorite command, right? When all else fails, and maybe you don't have knowledge of specific commands that tell you the things that you need to know whenever you're troubleshooting or verifying anything, you can use the show running config. The show running config will show you any subcommands for your context of um, different configuration sectors within your global configuration, right? So if I'm in the interface sector, right, I can go ahead and say, excellent. I can look under the interface sector and see for the context of the interface, I see the speed configured, I can see the duplex configured, right? Whenever we see this, right, in the context of speed and duplex, right, and auto negotiation, and we're confirming default settings. If we see no subcommands under here, then we can go ahead and deduce that the interface is using the default settings, auto negotiation, and the speed and duplexes are not manually set. Okay, right? So you can clear some doubt if you're troubleshooting, if you want to confirm, et cetera, right? But when we don't have the commands speed and auto under the interface, right? That means it's already set to auto in the background, right? So this tells you too that, hey, even if I went to global configuration mode and configured auto, that's the default configuration of the switch in the first place, right? So that's another way you can go ahead and confirm, hey, auto negotiation is the default setting of this interface and it's actually configured as such. Okay. All right. This is just a little way where you can just test it, right? And put it in. Okay. All right. And you guys can see this on the previous slide. But again, you can do a show running config and just mention the interface that you're testing on, right? Gigabit 1/0/1, right? You can make that change on an interface, add the changes, and then just see the result for that interface here. You don't have to look at the entire running configuration. Okay. Typically within a production environment, there is a lot of configurations, right? Depending on the complexity of your environment. So you may not want to go through the running configuration. So you can just, zone in and, find what you're looking for. Okay. So there is, and I think I missed a slide. So let me pull this over, right? Let's look at this section of the book. Okay, let me scroll on. One of my favorite. Um, and I think I do have a slide on it. Let me go ahead and see. Yeah, it's right here. All right, boom. There we go. So one of my favorite commands on Cisco devices is the show interface status command. Right? Why? Right? Um, if we do this command, right, the output is going to show us, right, um, different, you know, different results for the different columns, right? To note, and of course, speaking about this chapter, is going to show us a column for duplex. It's going to show us a column for speed, right? And it's going to show us the type of interface and what the interface is capable of, right? So we see a couple of results, right? We see duplex, A, and dash full, right? A dash full, what does that mean? That means full duplex with the A dash, meaning the switch learned the value using auto negotiation. Let's talk about A dash 1,000, right? Under speed. A dash 1,000, or no matter what speed, right, means that the switch learned the setting using auto negotiation. Okay, let's talk about auto. Okay, so under the show interface status command, right, under auto, right, this is saying, right, the interface will use auto negotiation when the link physically has a connection to an endpoint. Okay, so we have a connection for gigabit 1/0/1. There's nothing connected to anything else, but you can tell, right? Hey, it's ready to go, and this is what it's capable of. Make sense? And again,
Yes.
jumping ahead, I want to show you guys something, right? I know this is a little bit advanced, but this is kind of cool. We see here we have a connection on 10 gigabit 1/1/1. We see the duplex is set to full. That means it's statically set, right? We see the speed for 10 gig. We don't see an A or dash A or anything. This means the speed was statically set. Does that make sense?
Yes.
Okay. Okay. Just wanted to show you guys that. Okay. All right. So let's keep going and let's break down this, right? And maybe my pen can handle it, maybe it can't. So there's another command, right, that gives you a little bit more information, right? We can use the show interface command, right? And what the show interface command does, it gives you additional auto negotiation data, right? So you can see the output. We do a show interface gigabit 1/0/1, right? And we're just going to focus on the highlighted text for now, right? So we saw before, right, in the show interface status, it gave us some information, right? And it's going to show us the speed and the duplex for that link, right? Um, but we can also see a couple of other things, right? We're going to see this and this, okay? We can read here, it says gigabit Ethernet 1/0/1 is up. We're also going to see that line protocol is up and it's telling us it's connected. That line alone is telling us respectively, layer one and layer two is connected and working on this interface. Okay, that's the first thing, right? We also see that we have full duplex, 100 megabits per second, and the media type. What we saw in the previous one, right? But this is where you can go ahead and see, right? Now, it gives some insight to, whenever you use the show interfaces command, um, about on auto negotiation, right? But it's not going to give everything, right? Um, so let's look at this, right? So if we look at that same command on gigabit 1/0/2, same, same difference, right? In a non-working state. That interface is down. Layer one and layer two shows us down, right? But we can see, right, that even though it's down, it's ready for auto negotiation. Auto duplex and auto speed is set. Does that make sense? So this is what it looks like up here in a working state for auto negotiation. Does that make sense?
Yeah.
Okay. All right. Let's move forward. All right. So let's talk about setting the speed and duplex manually, right? So if we go ahead, we go to global configuration mode and we go to the context of the interfaces, right? We can set the interface's specific speed and duplex, right? In production networks, right? Um, Cisco is always going to recommend you to use and trust auto negotiation, right? Similar to what Claude said, and I'm paraphrasing, right? Don't be afraid to open up a book, but also to add on to that is to don't be afraid to get into your lab and test some of these theories, right? So, you know, just to prepare for your exam, cover all types of combinations, right? If you want to configure, right? If you want to configure the settings instead, right? Cisco recommends that you configure both devices on the ends of the links to the same value. Okay, let's look at this example, right? Um, let's say Mykevia went ahead and configured on switch one. Hey, interface gigabit 1/0/19 has a speed of 1,000 and a duplex 4, right? And then she reached out to Geary, right, and say, hey, can you configure the same thing? On gigabit interface 1/0/20 on switch 2, right? This is what it looks like, right? And what Cisco recommends and what you'll be tested on your exam to have a connection from endpoint to endpoint um, in a working state. Okay, you have to configure these settings the same on both sides. Okay, let's look at what it looks like in the CLI, right? So for my Kivia switch, we have here interface interface gigabit 1/0/19. She statically has the speed and duplex configured, right? On Geary switch, we have the same thing. Speed and duplex is statically configured. Okay, that's why our connection worked, and that's why it's up, right? So if we go to Geary switch and we go to verify this, right? We can see, right? Let's look at my Kivia switch, right? Um, we see, and I think they had a mistype here. We see for gigabit 1/0/19 that the status is connected, duplex is full, there's no A in front of it, and the speed is 1,000, right? Layer two is up here, and we have full and 1,000, right? And that show interfaces command, it doesn't tell you in a working state that it's using auto negotiation, right? But in a non-working state, you'll know. And of course, if you run this alongside with show interface status, that it'll tell you, hey, it's running in auto negotiation. Okay. Just to note, and let's go ahead and cover this note down here on some Cisco Catalyst switch ports, configuring both speed and duplex disables auto negotiation on that port. Okay. On others, it does not. In real networks, should you ever need to configure both the speed and duplex to specific values, take extra care to confirm that the speed and duplex match on both ends. Okay, that's the word from Cisco. So in earlier chapters, we spoke about the topic of auto MDIX. Okay. Um, and that's related to different UTP cables, right? Crossover is straight through, right? We're talking about pinouts, right? And we touched on that, if I'm not mistaken, in chapter 2. So if you're unfamiliar with it, read chapter 2, Fundamental of Ethernet LANs, right? So we spoke about how auto MDIX changed the game, right? Um, and of course, the short term, the short name for auto MDIX, the long name is automatic medium dependent interface crossover, right? So when auto MDIX is enabled, right, which of course is enabled by default, it gives the Ethernet interface the ability to sense when the attached cable is using the wrong cable pinout, right? And to overcome this problem, okay? So for instance, of course, we have a link between two switches, should use a, by definition, right, should use a crossover cable pinout. If the cable has a straight through pinout, Auto MDIX jumps in and says, right, that feature, it goes into work and it says, I can sense the issue and I can swap the pairs in the interface electronics and achieve the same effect as a crossover cable. Okay. All right. So figure 7.6, right? An example 7.7, they basically show you guys how this works, right? Typically switch to switch, we should use a crossover cable, right? But for this sense, I went ahead and picked up the wrong cable. And of course, I'm panicking. I'm thinking DeMarco, Makini, and Geary, my bosses, are going to yell at me. But thank God for Auto MDIX. It's going to go ahead and do its inner workings and solve the issue of wrong pinout. Okay. By default, like I stated, right? MDIX is configured on all Cisco interfaces, right? There is a command called MDIX auto, right? A sub interface command that you can go ahead and put in, right? It's not going to appear whenever you try to whenever you try to go verify within your show running config interface command. Okay, because again, it's by default. Okay, now outside of the CCNA at a higher level, there is a show running configuration command and a startup configuration command that shows you, and I think it's show run configuration all, that shows you everything configured. It's a large output, so I would recommend outputting to maybe external text, but it shows you everything that's configured. Um, Everything that's configured on that switch. Okay, pretty cool stuff. I don't advise it within a production environment because it's going to make your CPU work, and it may halt the CPU. So just be careful, right? But the purpose here, right, to get back on track is, again, you guys know how MDIX, Auto MDIX, how it works on Cisco switches. And this is just to expand on what we were talking about in chapter 2. Okay? But what does it look like in a non-working state, right? If I were to disable Auto MDIX, right, just on one side, right, we're still using this example, the straight through, right? I'm using the straight through cable that I picked up at the wrong store, right? If at any point that I disable Auto MDIX on one side, right, but the other side still have Auto MDIX set defaultly, right? Um, what's going to happen is I'm going to have errors, right? The link is going to go down, right? It's going to bounce, right? Because I have the wrong cable pinout. Okay, so those electrical signals between both switches is going to be unrecognizable, right? Because at a fundamental level, I'm using the wrong cables. Make sense? So if you disable, right, Auto MDIX, if you're going to do it on one side, you have to do it on the other. Okay, with great power comes great responsibility. Some great guy in the Marvel universe said that. You know, don't quote me. All right, let's move forward. Okay, let's talk about managing switch interface configuration. Okay. Um, and you know what? We're actually getting up there on time. So let's stop here. It's almost been an hour now. Let's stop here and we'll do a part 2 of chapter 7 on Sunday. Okay, guys?
Alrighty. This was good. Thanks, David. Appreciate
No
it.
problem. No problem, guys. You have a great day.
Uh,
Thanks. You too.
Thanks, Dave.